All right. So, looking at number 3, giving us a little bit of room here. First term is -1 to the 1 plus 1 power over 1 squared. What is -1 to the second power? 1. And what's 1 squared? 1. So the first term is 1, right? Second term, -1 to the third power, because 2 plus 1 is 3, over 2 squared. What's -1 to the third power? -1. What's 2 squared? 4, right? And then the third, you're going to get +1/9, right? And then fourth, -1/16. It's going to alternate, and then you're just taking the term and squaring it for the bottom, right? But sometimes you can see the pattern developing pretty quick. Does that one make sense? So when it's written this way, a sub n equals, and there's no a sub n minus 1s like number 5, whatever term we're looking for, we put in place of n, right? And just figure it out. If I was looking for the 10th term, I'd put a 10 in for the n in the exponent and the n in the denominator. Okay? All right, looking at number 5. This is when we have that a to the n minus 1. What did we say that was yesterday? Previous term. It's called a recursive rule. Okay? So in order to do these, you need to know the first term to get started, so you can get the second. Use the second term to get the third. Use the third term to get the fourth. Okay?
You just put the first term into that thing.
All right, so when I'm looking for the second term, what's n? 2. And then a sub n minus 1, the previous term, which would have been the first term, I put in that spot. That's what you asked, right, Chase?
Yeah.
So the answer for the second term is 4. To get the third term, what's n? 3. And then use the previous term, which is 4 now. So the answer is 12. To get the fourth term, n is 4. And then it's going to be 12 because the previous term was 12. So I get 48. All right? That's the one that gives us a little trouble once in a while. Remember, when you see that subscript n minus 1, okay, that's just telling you that you're using the term that just came before it in that spot. Or I like to say the previous term. Okay, questions? All right, so that was just a quick review of yesterday. Today, we're going to do summation. Okay? So, here's a quick review of factorial. We did this yesterday already, right? When we see that exclamation point, we call that factorial symbol. So we say 5 exclamation point, we say is 5 factorial. And again, that means 5 times 4 times 3 times 2 times 1. If you didn't have that symbol, because we have those symbols in our calculator, you can just put it in your calculator. But back when I was in your age in high school, back in the 70s, I had to do it like that, where I would, eliminate numerator and denominators that were the same, and then make it a smaller problem for me to do. So 56 times 6, I think it was 336 was the answer. But the stuff that we're going to do today, you'll see the exclamation point in that factorial. Yes?
Why did 8 only go down to times 5? It's just plus. It only goes down 3 times.
Well, I knew that these two are the same. I knew that those two are the same, so I know those will cancel each other out. So all I had to worry about was the 8, 7, and the 6.
Why doesn't it use 4, 3, 2?
Well, it does, but remember, that's, this and this are gonna be both of those, right? All those are canceled.
She already knows that it's 122. You have to go down until they cancel.
That's what I would do, yeah. But again, you could just do this in your calculator. Where was that again? You guys remember?
Where was it at?
If I wanted to do 8 factorial, I'll go 8, then go to math, and you want PRB for probability to be highlighted. If you have the little scientific calculator, there should be a PRB for probability button. All right, so you highlight the PRB, and then if you look for number 4 there it is. So that's 8 times 7 times 6 times 5 times 4 times 3 times 2 40,320. Okay? All right, let's look at this summation stuff. So this is the new stuff today. All right, so summation notation is a convenient way to find partial sums. The sum of the first n terms of a sequence a sub n is represented by using the Greek letter sigma. So that fancy looking E is called sigma. And it means that we're going to add up all the terms. So we're doing the same thing we did yesterday, but the extra step is adding up all the answers we got, basically. Okay? So this is, when we look for a sum of a sequence, we call it a series. It is a finite series because it is the sum of a finite number of terms. Remember, sum means to add. The letter I is called the index, so it'll be I or X or K. They'll use all kinds of variables. It doesn't matter. All right? That's called the index, and then whatever number's in the below here is called the lower limit, and whatever number's above it is called the upper limit of the summation. All right, so what does all that mean? Well, let's look at an example. You'll understand better when we go through an example. All right, so they're using I for this again. All right, so I need to put 1 in for I, 2, 3, and 4. So this tells you where to start to put in for the variable, and that tells you where to end, putting in that number for the variable. But you put all of them in between. So I got to put 1, 2, 3, and 4 in for I. Okay, Ashton? So I'm just putting 1, 2, now 3 in for I, and 4 in for I. So that's what that means to do this. So you find each answer. This is 1/2, 2/3, 3/4, and 4/5. And whatever that answer is, that's the answer to that summation problem, or the answer to that series. So go ahead and figure that out for me, somebody. In this problem, it probably doesn't make a difference, but I would get in the habit, if you're adding fractions, to put them in parentheses. No, a little bit more than that, Chase. We're adding all those up. So Kennedy got it. That's the answer.
2 point something.
2 and 40, or 2 and 43/60. You wrote it as a mixed number, but usually we write it as an improper fraction. Questions on what we did to get that? Everyone understand why we used 1, 2, 3, and 4? Okay. All right, so what numbers do I start with putting in for x? 2. What numbers do I end with? 5, yeah. And I got to use 3 and 4 as well. Okay? So this one is -1, and then x is 2 to start, plus -1, x is 3 now, plus x is 4 now, and x is 5. So wherever I see an x, I put a 2, because my lower limit's 2, and then I put a 3, put a 4, and then I put a 5, and that's where I stop because my upper limit's 5. Does that make sense? What you would have to do to figure this out? Not that hard, just takes a little more time than yesterday, right? So this is +1 times 4, which is 4. This is -1 times 9, so that's a -9. This is +1 times 16, so 16. And then it's -1 times 25, which is -25. Okay. When I see positive and negatives like this, I usually do this. I'll take the positive numbers and add those. And I'll take the negative numbers and add those. And then I'll find my answer by doing that problem. It doesn't matter what order. You go 4 minus 9 is -5, plus 16 is 11, minus 25 is -14. Making sense? Any questions? Okay. I want you to do 2 problems for me, and then we'll call it a day. This is what I used last year when we were quarantined. Let's do these two. 50 and 52. Yeah, that's a 1 and a 7. This is a 1 and a 6. Morris Brothers, Chad. Long hairs, Morris Brothers. No, I didn't tell. I should say something.
I didn't know what.
Right.
Those are pretty good. Jack's got it out there too. He's gotten a lot taller. He used to be- Oh, yeah.
No, no, that doesn't change. The only thing you switch out is wherever you see the eye. Okay, so what's the answer then? Yeah, well, what, you gotta add them up. Then. Don't forget to add them up.
That's the one answer, correct?
Yeah, then that's, yeah, but you gotta add them up then, because of that, the E thing. You got all the right terms, you just gotta add them up.
Alright.
Yeah, I'm gonna say it one time. My nose number paper.
Good, point. That would be neat, right, because so you're practicing.
All right. I think that's, it's in here.
How do I do the plan? So
I mean, those are right, but for some reason, oh, this.
Oh,
Let's go.
No.
Why did you
Right. Yeah.
My draft book.
Second header at a time.
Let's go. But you're the sixth one.
Won't go. Sometimes it goes to the ones that are what you did.
Yes, sir.
Where's your answer? You the answer.
We leave.
Those are all right, but that's a 42, isn't it?
Or, oh, should be 12.
You're probably right, I don't know what, I know what the fraction is. Let's put it in. All right, you guys have done good. So, did you see a pattern happen with 50?
Yeah.
What's 2 times 1? 2 plus 1, 3. 2 times 2 is 4, plus 1 is 5. 2 times 3 is 6, plus 1 is 7. What do you notice? It's just those odd numbers, right? So you need those 7 odd numbers, 9, 11, 13, I think that's 7, right? 1, 2, 3, 4, 5, 6, 7. So, you know, if I'm not using my calculator, which a lot of times I don't, there's 20, there's 20, there's 20, so what's the answer? 60 plus the 3, right? All right? What's 1 times 1 plus 1? 2, right? What's 2 times 2 plus 1? 6. 3 times 3 plus 1? 12. 4 times 4 plus 1? 5 times 5 plus 1? 6 times 6 plus 1? 42. What'd that come out to? 6 sevenths. Very good. So, just like yesterday, except what are we doing at the end? Adding all the terms together. Okay? Good job today. It brings at 1:53, 2 minutes.
Yeah.